Using transformations, lesson 21 notes. You should have already uploaded the notes from Schoology into Notability and attempted to do the review. I told you in the update that you should use decimals for your final answers. You could have had it as improper fractions or mixed numbers as well. I just thought if I told you to everyone to have it as a decimal, we could all be on the same page. So go ahead, pause the video, and check your answers to the review. Okay, using transformations. This is going to take our 4 lessons on transformations, translations, reflections, rotations, and dilations, and it's going to put it all into one lesson. We're going to do more than one type of transformation per problem. So, for what I'd like you to do now is pause the video and get your definitions and fill in the blanks done. Okay, rigid motion. Rigid motion changes only the position of a figure, resulting in the image being congruent to the preimage. For rigid motion, the image and the preimage are congruent. So if they are congruent, that means it excludes dilations. If it's a rigid motion, it excludes dilations. So examples of rigid motion include translations, rotations, and reflections. Because if you remember, in translations, rotations, and reflections, your preimage and your image are congruent. However, in a dilation, they are similar, not necessarily congruent. 2 figures have the same orientation if the vertices of the preimage and the image are in the same position compared to one another or to the center of the figure. We've talked briefly before about orientation, but this is just going to go into a little bit more detail. So we're going to talk about the orientation for translation, for rotation, and reflection, because right now we are talking about rigid motion. Okay, so in a translation, if you look at the 2 triangles I have, A and A prime are directly north of C and C prime. C and C prime are directly west of B and B prime. And B prime are southeast of A and A prime. In other words, they have the exact same orientation. They have the exact same orientation. So for translation, you will have the same orientation. So when we go to do these problems later on, if you see 2 figures have the same orientation, that means there has to be a translation that occurred. Rotation. Rotation. A is directly north of C, but A prime is northeast of C prime. C is directly west of B, but C prime is northwest of B prime. B is southeast of A, but B prime is southwest of A. Okay, so in other words, if you look at the 2 figures, they don't have any type of similar orientation. It's not the same at all. In other words, for rotation, it is a completely different orientation. For rotation, there will be a completely different orientation. Reflection. A is directly north of C, but A prime is directly south of C prime. Both C and C prime are directly west of B and B prime. B is southeast of A, but B prime is northeast of A prime. So if you look at these, so C and B, and then C prime and B prime, they're kind of lined up the same way, but for the top triangle, A is north, where in the bottom triangle, A prime is south. Therefore, if you look at these, you could tell that it's a reflection, it flips. So it is called the opposite orientation. For reflection, it is opposite orientation. Okay, so just to review, translation will have the same orientation. Rotation will have a completely different orientation, and reflection will have an opposite orientation, where letters are across from one another. So translation is same orientation, rotation completely different orientation, and reflection will have opposite orientation. All right, so that's some definitions and the review for lesson 21. If you have any questions, let me know.